Hello, sister. So today I thought we would go over some of the basic concepts of algebra, including where algebra comes from, some of the history of it, who originally thought of it, and then look at the basic properties. And we're going to look initially at some of them in equation format, and then I'll give you some examples so that you can get some ideas of how we're going to work on in the future on algebra problems. Now this is the text from Baghdad, written by a man named Al-Khwarizmi in about 830 AD, and this is one of the earliest texts that we have referencing algebra. So I wanted to write this out phonetically so that you could actually see where the word algebra comes from. Now, this actually translates to the Compiguous Book on Calculation and Balancing. Now, I'm not even going to attempt to say this whole thing, but if you look right here, Algebra, this is where the actual root of the word algebra comes from, is Al-Jabr. And as I said, this was the text by Al-Khwarizmi. Now, an important part of algebra is the Cartesian plane concept, named after the Italian philosopher René Descartes. And as you can see, it's divided into 4 different quadrants. You have quadrant 1, which is entirely positive. You have quadrant 2, which is negative along the x-axis and positive along the y-axis. You have quadrant 3, which is completely negative. And then you have the 4th quadrant, which is positive along the x-axis and negative along the y-axis. Okay, so I've condensed a couple of the associative and distributive properties together so that we can get a look at them, because I'm pretty sure you're aware of how this sort of thing works, but just in case you're not, it's an important thing to know before we actually start dealing with algebra problems. And so what this is telling us is that if you multiply any number by something within a parentheses, within the parentheses here, essentially what you're doing is multiplying the number by each of the individuals within the parentheses. So A times B and A times C, which is why it's equal to A times B and A times C. And this is just a simple distributive property. So let's look at an actual example. So let's say you have 2, 3 plus 5. Essentially, what that's telling us to do is to multiply 2 by 3 and 2 by 5. So that's 2 times 3 is 6, plus 2 times 5 is 10, which makes our answer 16. Okay, so now let's begin defining some algebraic terms and looking at some actual algebra expressions and how to solve them. So let's look at identifying what our terms are. So an algebraic expression would be something like 5x minus 1 over 7. This would be an algebraic expression. Now, what are the terms here? Our terms are 5x and 1 over 7, negative 1 over 7. Now, what are our coefficients? Our coefficients are everything that involves the terms without the variable. So our coefficients are 5 and negative 1 over 7. So that's pretty easy. Let's look at another algebraic expression. 2x squared minus 6x plus 9. Now, take a moment and think about what the terms for this algebraic expression would be, and then what the coefficients would be. Okay, so you should have taken that moment to figure out what you thought the terms and coefficients would be. The terms, remember, are each individual piece, so our terms would be 2x squared, negative 6x, and a positive 9. And our coefficients are each ones that are in front here, so it's 2, negative 6, and 9. So here's something you might typically see for, really basic algebra. You'll be given the expression negative 3x plus 5, and you'll be giving given a value for what x is, and in this instance x is going to be equal to 3. And the way to solve this is pretty simple. You just substitute in the value for x into where you see x in the equation. So it would be negative 3 times 3 plus 5. And then using the properties we looked at before, we're going to distribute the negative 3 into the parentheses. And that gives us negative 9 plus 5. And now we can solve that pretty straightforwardly as just being negative 4 is the answer to this particular expression. Okay, now take a moment. This one's a little bit trickier, and see if you can solve this one on your own. In the numerator we have 2x, in the denominator we have x plus 1, and we are given that the value of x is equal to negative 3. So take a moment, pause the video, see if you can figure out what the expression is equal to, and then come back and I'll work it out with you. Okay, so let's begin by plugging in the negative 3 to our x values. If we plug in, we have 2 times negative 3 over negative 3 plus 1. And that's equal to, now we are going to distribute in our 2 to our negative 3, which gives us negative 6 over negative 3 plus 1 is going to be negative 2. So we have negative 6 over negative 2, which is equal to a positive 3. And that's what you should have gotten. Okay, so the last thing I want to look at with this particular section is inequalities and absolute value symbols. So you should recognize that these first 4 are the symbols for inequalities. This one here is to indicate that something is not equal, and this is the 2 bars around the x symbolize the absolute value. And so let's say we have 2 values, 4 and 8, and we want to use an inequality sign, and we would say to indicate which one is greater than the other one. Well, we would do it like this. We would say 8 is greater than 4. And an easy way to help you remember this is, and this is probably simplistic, but it helped me when I was in school, is that if you imagine the inequality sign as an open mouth, and it wants to eat something, it's always going to eat the larger value, right? So if you imagine it as, a mouth, it's going to be eating the 8 over the 4. Or you can look at it as an arrow, potentially, that is indicating the smaller value. So whichever way the arrow is pointing is that it's indicating the smaller value. Now we also have the inequality sign with the bar under it. That means that it can be equal to the value, which means that we're going to be looking at something along a number line, for instance, where a number or a set of values can be either greater than or equal to that particular value. Now, let's look at our absolute value here. So, what an absolute value indicates is it is whatever number is within the bars is going to be a positive number. And that's the best way to think about it. So let's say we have something like 3 minus 4. Okay. We know that 3 minus 4 is going to be equal to negative 1, right? And that's just how let's write that a little bit bigger here so we can see it. 3 minus 4 is equal to negative 1. Now what if, however, I did this, 3 minus 4, as an absolute value? Now what we would end up getting is the absolute value of negative 1, like that, which is equal then to 1. Because the bars, the absolute value, always indicates that this inside value must be positive. So whenever you see those bars, go ahead and tell yourself that any negative number, if this expression ends up giving you a negative number, to just change that number to a positive, and you will have solved for the absolute value of. Okay, so all the things we looked at today are pretty simple, very basic introduction to algebra, just to kind of get your mind back to thinking in those realms. Gave you just, kind of a brief history of where algebra comes from. We looked at the Cartesian plane. We looked at the associative and distributive properties. which is, basic arithmetic sort of thing, and gave a couple of algebra expressions, some definitions, and then we worked out a couple of problems together, and then we looked at some signs, some inequality signs, and the concept of the absolute value. Next time we'll go into a little bit more depth with graphs, with the Cartesian plane, with how to plot points. We will do solving, y equals mx plus b. We'll start looking into that sort of thing next time. But I wanted to spend this particular section just really reviewing the basic concepts of algebra. And I hope it was informative, and I'll see you next time.